Hello, my name's Andrew Bradley. I'll be introducing our project developing a statistical methodology for the assessment and management of peatland, also known as StAMP, on behalf of my colleagues from the University of Nottingham and the University of Highlands and Islands. So, why should we care about peatlands? Well, as you can see on the map on the left, peatlands tend to be in out-of-the-way areas, in highland regions or in remote agricultural areas. But you'll notice that peatland does actually cover 10% of the UK land area, which means it's quite important in terms of carbon storage, regulating water quality and quantity, and it provides a unique wetland habitat. However, 80% of that is actually damaged, so it doesn't function properly. So the UK has an approach to restore and conserve peatland through the National Peatland Strategy, and this is supported by a framework but from the IUCN peatland programme and their peatland code. As a result, the governments around the UK have committed large sums of money over a number of years. So these monies are then distributed between different peatland restoration stakeholders, and this is where the problem begins, because stakeholders use different criteria, methods and appraisal of peatland restoration, and this makes it very difficult to measure success across the board. And this is because there isn't a reliable benchmark of peatland condition which would ensure cost-effective investment and to demonstrate the investment outcomes across the board. And this comes about because there are no consistent cost-effective ways to monitor the condition of peat over large and remote areas. So imagine trying to measure this area in the picture in the background in great detail. So our solution in StAMP will be to utilise gridded spatial and temporal data from satellites, which will cover the whole area. We'll develop a novel method to determine the spatial and temporal changes in peatland conditions from the surface motion time series of the satellites. And to achieve this, our aim is to extend an emerging statistical method, object-oriented data analysis, otherwise known as OOAD, on these spatial temporal data sets. The spatio-temporal data that we'll be using come from Sentinel-1 satellite radars. This is a 6-day repeat measurement of the motion of the peatland surface, and it's measured in a 20 by 20 metre spatial grid. The way this is done is by the satellite repeatedly measuring the same place, and when the ground deforms, it can detect a change in millimetres. The algorithm is obviously much more complex than the diagram suggests, but what we end up with for each 20 by 20 metre grid square is a time series like the one on the right. This is 5 years worth of data, and this is over good sphagnum wet peat, and what you can see is we have a reasonably clean time series apart from a little bit of jaggedness and noise, and within each year you can see an up-down movement of the peat. These time series are typical of what we find in peatlands. Our objectives are to develop the OODA approach with spatio-temporal time series, detect change points in time and change regions in space on the time series, develop classifications, and develop predictive models from our understanding of how the time series change. We'll then discuss the findings and requirements with stakeholders, as they might not understand what we find, and we may not fully understand what their requirements are. And from this iteration, we'll then improve our OODA peatland condition assessment tool. So below is typically what we may aim for. Here we have two time series with different restoration times. On the left hand side, restoration in 2015, you can see how the time series in black is beginning to develop like the sphagnum time series in the previous slide. On the right hand side, you can see how a noisy time series has then begun to develop seasonal characteristics, similar to the previous slide. When we've characterised these different change points and how they occur over space, we'll aim to make a classification and map it to produce something like the diagram in the centre. And from this, we'll use it to direct and appraise what the stakeholders have been doing. This is an example of how we might interact with the stakeholders in using the time series. And this was a pilot study we did with Peatland Action or Nature Scotland. And we have a polygon which was restored by removing the forest. So what we did was we looked at the time series on a year-on-year basis, and we classified each year according to whether the bog was in near natural conditions or in a degraded state. So you can see, moving from class 1 to class 4, that's degraded to a near natural state, that the red area of the pie chart is gradually being reduced and the yellow area is increasing, and the green areas are slowly increasing as well, indicating an improvement in the bog after restoration. So just to finish now, so the main outcomes of our project will be that OODA will identify the state of a landscape before and after land management and form a better understanding of management decisions on the peatland system. And this will facilitate enhanced decision making to measure and predict the peatland system. Thank you for listening.